Greetings and a warm welcome. In today's session, we're here to discuss the importance of grounding and ground wires in buildings. Here is some humor. If you want a bigger budget, more money for operation and maintenance, simply ignore the importance of grounding standards in your building. The discussion today will focus on reasons for grounding systems in commercial and industrial buildings. Let us set aside the jokes and seriously understand the meaning of grounding. What is grounding? Grounding in buildings refers to the electrical practice of connecting electrical systems and devices to the earth, or a ground reference point to ensure safety, functionality, protection against electrical faults, reduce maintenance and downtime costs, noise and interference reduction, compliance with electrical codes. Grounding provides a path for electrical current to flow safely to the earth in the event of a fault, such as a short circuit or equipment malfunction. This helps prevent electric shocks to individuals and reduces the risk of fires or damage to equipment by directing excessive current away from the system. Grounding systems serve as a pathway for fault currents, directing them to safely disperse into the ground instead of posing risks to individuals or damaging equipment. Properly installed and maintained grounding systems help prevent electrical shocks, fires, and damage to electrical appliances, making them fundamental for electrical safety in buildings. Grounding helps stabilize electrical systems by providing a reference point for voltage levels. It helps maintain voltage within safe limits, reducing the risk of electrical surges or fluctuations that could damage devices or disrupt operations. Grounding systems reduce maintenance and downtime costs. To function as per manufacturer specification, connected electrical, mechanical, electronics, and computer equipment in data centers, hospitals, laboratories, or industrial plants often require isolated grounding systems. This separation prevents interference, noise, or fluctuations in electrical potential that could disrupt the functioning of the equipment, that often results in high maintenance and downtime revenue costs. Proper grounding minimizes electromagnetic interference, EMI, and radio frequency interference, RFI, which can affect the performance of sensitive electronic equipment. Grounding shields against external interference and maintains signal integrity in communication systems. Electrical codes and standards often require proper grounding practices to ensure the safety and functionality of electrical systems in buildings. Following these codes ensures that grounding is done correctly and in accordance with established safety guidelines. To summarize this session, grounding in buildings refers to the practice of creating a connection between electrical systems and the earth to prevent electrical hazards. It involves the use of grounding electrodes, typically rods or plates, to safely divert excess electricity to the ground in the event of a fault or surge. This process ensures that electrical current flows safely, minimizing the risk of shocks, fires, or damage to appliances and equipment by providing a path of least resistance for electricity to dissipate harmlessly into the ground. To guarantee safety, compliance, and effective protection against electrical dangers and damage to connected equipment, it is crucial that trained professionals install, maintain, and regularly inspect grounding systems in buildings. We thank you for tuning in to this presentation. Please also watch our presentation on understanding the difference between the neutral and ground in electrical networks. For further information, please reach out to our distributor. Have a wonderful day.